wonderful thing, the internet. It wasn't available when I was at school. Okay, density, what is it? Well, first of all, let's address this little problem here. Schools love to present conversion triangles. Well, it's not really their fault, it's the government insisting on they do it. I'm not so keen on these. I'm not so keen on these at all, because, you know, you could draw your triangle with your lines and then think, oh, I don't know what goes where. You can get stuck. So I'm going to avoid that. I'm going to pick as an example concrete. Now, I've asked for density of concrete. This is a typical density. There's all sorts of things that can affect it, you know, the different materials, how much water content there is, sand, the type of sand, gravel, but I'm going to use that number because I need a number to use. But what I'm going to be doing is I'm going to convert that to kilograms per cubic meter. So we're looking at this thing here. Using the values given, we had 2.4 grams, and that was in relationship to the volume of 1 cubic centimeter. Fraction format. This is the same as them saying 2.4 grams per centimeter cubed. That is just another way of writing that. We're going to be using this one. Now we need to have some information, because we've got to convert that to some number, question mark, kilograms all over 1 meter cubed. That is our objective, to have this starting with that. We need some information first, so grams into kilograms. We know that, well, first of all, look at the word kilo, 1,000 grams. So 1 kilogram is 1,000 grams. So look, we have 1 kilogram equals 1,000 grams. Overall, they have the same weight, it's just a different way of writing them. So that is one of our conversions. Now, centimetre to meters, that's not a very good M, is it? We know that centi, cent, centurion, century, 100. One of these is 100th of a metre. So we have 100 centimetres equals 1 metre. But we have volume in both cases. So we need to consider volume. Alright, let's have a look here. Let's draw a cube, pretending that the diagram is absolutely perfect. Everything is true to angle and length, and we have this. So let's pretend each one of these lines has the same length. That one there, we're going to give the size of 1 metre. That one there, the size of 1 metre. And this one here, the size of 1 metre. But 1 metre is 100 centimetres. So in fact, that is exactly the same total length as 100 centimetres. That is exactly the same in length as 100 centimetres, as is that one, 100 centimetres in length. Cubic, 1 times 1 times 1 metre cubed. So we have 1 metre cubed, exactly the same in volume as 100 times 100 times 100. So in fact that is 3 lots of 00. 1, 2, 3. And that is not really a lot of room, is centimetres, very small. So 1 cubic metre is that number of cubic centimetres. Okay, we've got our information that we need. Let's section that off so that we know that is our reference area. Step 1. We need to convert grams to kilograms. Am I going to do it that way around? Let's do the volume first. Centimeters cubic to meters. So look, we have 2.4 grams, which is not going to change. 1 cubic centimeter. Now what we want to do, put a multiplying the line across. We want to get rid of the centimeters and in its place put meters. Now to get rid of centimeters we put the same thing up here. Cubic centimeters, so this one here will be cubic meters. Those two will cancel out. Okay, so we end up with one underneath. The unit of measurements cancel out. Units of measurement behave the same way as numbers. So the centimeter cubed cancels centimeter cubed. Now in ratio we have 1 cubic meter is that number of centimeters. So let's put that number there where this one is. Oh, I don't know if I've got enough room. Let's change that, shall we? And okay, we have 1 pair, 2 pair, 3 pair, centimeter cubed. That cancels that out. And we have 1 meter cubed. That is the ratio which matches this here. So we have now got 2.4 times that. Now I'm going to keep it that way. 2.4, not going to write the grams just yet, times 1 pair, 2 pair, 3 pair. That unit of measurement has gone. That is the only one that's left, grams. All over, the number 1 times the number 1 is 1. That unit of measurement has gone. That unit of measurement is the only one that's left. See, it forms a logical step, which is why I do not like those triangle conversion systems. This is far more logical and directly connected with the units that you're using in their relationship. Okay, so that's completed step 1. So we have now converted, which is cubic centimeters converted to cubic meters. Now step 2. We've done the volume, we now need to do the weight. We need to do grams converted to kilograms. This is our end point here, which is our starting point over here. So we have 2.4 times 1 pair, 2 pair, 3 pair grams, all over 1 cubic meter. See, that is that. The end point of this one is the starting point of this one. We need to convert grams into kilograms. Well, our relationship, look, we can have 1 kilogram to 1,000 grams, or if need be we can turn it upside down the other way. But as it happens, this is the right way because this is underneath and that is on top, which means they will cancel. So we times 1 kilogram all over 1,000 grams. See, this is the ratio. So we're using the ratio to do the conversion. Right. Unit of measurement cancels. Gone. Now we can get rid of some of the zeros. That one cancels that one. That one cancels that one. That one cancels that one. What in fact we've done is we divided the bottom here. Yeah, no, I won't go there. Alright, they cancel. They cancel. So that little action here just leaves 1 underneath. So we have 2.4 times that, 1 cubic meter times 1, because those zeros have disappeared and that unit of measurement of gram has disappeared. Okay, so what we end up with here is there's our 1 cubic meter. 1 times 1 is 1. The only unit of measurement left is that. 2.4 times that. Now look, we got 1, 2, 3 noughts. People tell you move the decimal point. It's not quite correct, but that's what I'm going to do, because that's what everyone else does incorrectly. 1 decimal place. That's that nought. And I've got 2 more. 1, 2. So that is 2.4. 1, 2, 3 noughts. 1, 2, 3. The only unit of measurement that is gone, that is left there. That is your conversion. So 2.4 grams per cubic centimetre is exactly the same, has its equivalent, but using different units of measurement. It's 2,400 kilograms to 1 cubic metre. The numbers look different, but if you were to break this up into the size of 1 cubic centimetre, this weight here will be the same as that weight there.